Hi, this is Mr. Adler, and welcome back to Ciencia on Fuego. Today we're going to be mixing it up by talking about mixtures. A mixture is a combination of two or more substances that you can separate physically, as in not through chemistry. Let me give you an example. I like Skittles, but my favorite color is green. Skittles are a mixture. When you pour them out of the bag, you've got green Skittles, blue Skittles, red Skittles, purple Skittles, but I just want the green ones. Well, I could just physically take out the green ones using my fingers. That's a mixture that's really easy to separate physically. But some mixtures are going to require a little more science. Let's start with this mixture. This is a mixture I might find at the beach. I've got some water, and in it, I've got some rocks. Now, rocks are insoluble in water. That means the rocks don't mix in with the water at all. So for this, I can use filtration, which is when I use a filter to pull out the big rocks that aren't mixing in with the water. Here, I've got a coffee filter, and I've got a funnel. You've probably seen this filter at home. Your parents or your grandparents or your aunt or your uncle, someone probably uses something like this to make coffee. Except instead of coffee grinds, I'm going to try to catch these rocks with the filter. I'm going to hold up my funnel and my coffee filter, and I'm going to pour in my mixture. Now, all of the mixture went into the funnel, but now, when I pull out my funnel with my filter, my rocks are trapped in the filter paper, and here, I've got my pure water back. That filter, that coffee filter, was able to pull out the insoluble rocks. Let's keep talking about how to pull solids out of other mixtures. Now, what about this mixture? This looks like something I might find at the beach. I've got sand, I've got shells, but uh-oh, it looks like someone's been polluting my beach with these little metal objects. They look like staples. By the way, this is an important point to mention. Separating mixtures isn't just fun. It's also something we can use to clean up the environment, because sometimes things become mixtures we want to be pure substances, like just sand or just water. Now, I could go through and try to pick out all of the metal objects one by one, but there's another thing I could do. I know many metals are magnetic. So as a result, I can actually separate this mixture using magnetism. I've got my magnets right here, and when I go over the mixture, the metal comes right out. I can keep going. And look at all of those metals that jump right out of the mixture onto my magnet. That took me just a few seconds, but if I go through this just one more time, I'll probably catch all of the remaining metals, and I've completely cleaned out this mixture of sand and staples. Magnets are another really useful tool for separating mixtures. Speaking of the environment getting dirty, unfortunately, sometimes oil gets spilled into water. For example, we might have oil off the coast being pulled up from inside the earth, and then that oil might explode, or the tanker might rupture, and oil might go all over the ocean and harm plants and animals. Now, fortunately, there's a way to separate oil from water. If you want to separate two liquids that are immiscible, which means they don't mix, I can use something called a separating funnel. Now, a separating funnel is just any old funnel, but watch what I can do with it. I've got here a mixture of oil and water, and I've dyed the water red so it's easier to see. Now, if this were a real separating funnel, I would have a valve at the bottom of it that would hold the water in place. I don't have one, so I'm going to be a little bit gross and try to use my fingers. When I pour through, if I let this mixture settle, you might see that all of the oil settles on top. That's because oil is less dense than water. So once I let it settle, all of the oil is right on top, and all of the more dense water sinks to the bottom. So all I have to do now is open my funnel and let the water drain out, and then stop it before any of the oil comes in. Let me show you one more time. I pour. I let it settle. The oil will come right to the top. And then I let just the water go through. I made a little bit of a mess, but you can tell my oil is still on top. And here I've got pure water because I let the water drain out of my separating funnel before any of the oil can come through. Now, there's one more method of mixture separating that I want to show you. It's the most complicated, but it could save your life someday. It's called distillation. Let me explain. Pretend you're stranded on a deserted island. Your boat capsized and you're stuck there. You need to find clean drinking water, but all around you is salty ocean water. Can you separate that mixture of salt and water? Absolutely. Pretend this is the water around you, and I've made it a brownish reddish color just to show you it's not normal water, it's actually salty water that we need to clean up. Now, something we know about water is it evaporates when you add heat. If I add heat to this mixture, the water will rise up as water vapor, that's water in the gas phase, and escape and leave the salt behind. But that doesn't help us if we need clean, fresh drinking water. I don't want all of my water escaping as water vapor. I want to trap it. That's where distillation comes in. During distillation, you heat a liquid, but then you trap the vapor so that it can condense or turn back into liquid water. Let's take a look over here on my hot plate. I've got a metal can where I put some of my mixture, that salty water that I know I can't drink. I put a sheet of plastic wrap on top so that when the water vapor rises up, it's trapped by the plastic wrap. And then in the middle, I put some rocks. The rocks make sure that all of that water vapor is going to go down into the center and drip into a cup I put in the middle to collect the pure water. If we did it right, all of the salt stays at the bottom of the can. As the mixture heats up, only pure water can evaporate, condense on the plastic wrap, and then my water vapor will run down into the middle. Let's take a look and see how we did. I'm going to take off my plastic wrap. You can see even now that I've got some water vapor running down into the center. If I lift off my wrap, right there in the middle, I've got a cup with pure water inside. You can tell that where I started with this salty, nasty water, now I've got clean drinking water. I wasn't able to make enough in just a few minutes, but if you gave me enough time, I could turn all of the water here into clean drinking water just using my hot plate, my can, and my plastic wrap. One more time, mixtures may even look like all of the same thing. This mixture, the salt is completely dissolved in the water. It's mixed completely. But with enough science, I can physically separate any mixture into its component parts. Remember that and your science the next time you're stuck on a deserted island.